Okay, we've now seen a mechanical description of evaluation of procedures, both what happens when we define them and what happens when we actually use them, when we do a computation where we use the body of the procedure. We described a mechanical way of using environments. Let's look at a couple of examples to really drive home that process. Here's a simple example. Let's suppose I want to compute the power of some number to some other power, a to the power of p. I'm going to do it with just successive multiplication. I know that Python provides a built-in version of this, but I would say, for example, want to take a to the pth power, and I do it by multiplying a by itself, storing that result away, then multiplying that by a, then multiplying that by a, and just keeping track of how many multiplications do I need to do until I've done p of them, and keep track of the result and return it when I'm done. So here's some code to do it, and it's pretty straightforward. In fact, we just saw it earlier. It was my earlier example. I'm going to input some number for x. I'm going to input some number for p, and I'm going to make sure it's an int by doing a typecasting there. I'm going to set up an intermediate variable or a place to store the result, and then I'm just going to run through that loop where I'll print something up to tell me where I am, and I'll change the value of result. Let's look at an example to see that this does it. So if I go over to Python, I can load that computation in. It's now saying give me a number. I don't know, let's give it 3. It says give me an integer, let's give it 5. Oh, and it prints through the stages, telling me at each iteration what the current result is. It starts as 1, and then it's 3, and then it's 3 squared, and then it's 3 cubed, and then it's 3 to the 4th. Ooh, wait a minute. Didn't I want to take it to the 5th power? Well, notice that my print statement is just printing before I actually do the work. And in fact, when I'm done, what I've done is I've returned the value in result. And there it is, it's 243. Okay, we saw how that computation would take place previously. Now, let's capture it in a procedure. So I'm going to define a procedure called iterative power. There's the name. I'm going to give it 2 formal parameters, x and p. And then the body of the procedure is much like what I had for my computation before. I've got an internal definition of result, which I'm going to use. And the only big difference is when I am done with the computation of that for loop, I've got that special keyword return that says return the value of this expression, which is just the value of result, when I'm done. Let's try to see if it works or not. I've already loaded this over here, so if I say I'm going to iterative power, I'm going to compute that. Let's do 3 to the 5. It runs through exactly the same stages, and notice what it printed out at the end. It printed out the value of the computation. And in fact, if I were to bind this, say z is equal to iterative power of 3 and 5, runs through the computation, and if I ask for the value of z, there it is, 243.